I have to start by apologizing. The 2010 exam, for whatever reason, they used a weird font and my computer really didn't like it and I didn't even realize it. So you may have to go onto the AP Central website to find the solution to the 2010 exam because it definitely didn't include all of the terms. You'll just find big gaping holes on this solution. I apologize for that. Go on to AP Central to figure out what's going on there. Okay, in problem number 2, we have a mass on top of a roof. It's going to slide down the roof and it's going to land on a cart. Okay, done a very similar problem to this one already. We know the mass of the object is 6 kilograms, the length of the roof is 4 meters, the angle is 30 degrees, and they were kind enough to give us the rotational inertia of this bowling ball as it comes off the roof. Okay, part A, I guarantee most of you guys are going to lose points because of the way I teach, and I apologize for that. Notice the language here. On the figure below, draw and label the forces, not components, acting on the ball at their points of application as it rolls along the roof. Okay? So we have the force of gravity acting down. We have the normal force acting perpendicular to the surface. We usually break this force of gravity down into F down the incline, and then we know that the normal force is equal to the mg cosine theta. They're not asking for that in this problem. They just want the fundamental forces acting on it. They don't want you to break down this mg into components. They're very clear on that. So mg acting down, normal force acting up, and then at the bottom of the bowling ball we have the force of friction acting to the left. You, yes, would lose points if you broke this down into the force down the incline and the force perpendicular to the incline. Please be careful on the language on those problems. If you lose points there, it should not make that big of a difference. Calculate the force due to friction acting on the ball as it rolls along the roof. So this is kind of the opposite. We usually find the acceleration, and we do that by doing a substitution on the torque. Here they're actually asking us to do the reverse. They want us to find the force of friction by doing a substitution on the acceleration. So the mass times the acceleration is the net force acting on the bowling ball. That's equal to mg sine theta minus the force of friction. We then have to go to torque. Torque is equal to I alpha is equal to the force of friction multiplied by the radius. That's RF sine theta if you forgot. They gave us the rotational inertia and we replaced the angular acceleration with A over R. That's equal to the force of friction times R. And since I want to solve for the force of friction, I'm going to solve for MA as 5 over 2 times the force of friction. We then take that MA is equal to 5 over 2 times the force of friction, and we're going to substitute it in up here. So now I have 5 over 2 force of friction is equal to mg sine theta minus the force of friction. I have two friction terms, so I'm going to move the 5 over 2 over. That still has a minus sign. Move the mg sine 30 over to the other side. There's minuses everywhere. Those all become plus. And now I have mg sine 30 is equal to 5 over 2 times the force of friction plus the force of friction. We can calculate mg sine 30, and we get 29.4. That's now equal to 7 over 2 times the force of friction, and that means the force of friction is equal to 8.4 newtons. So this is a little weird because usually we solve for the force of friction here in the torque equation and substitute it back in to get the acceleration. Here they're having us do the reverse, which made me pause for a second. And I'm kind of cheating here by setting MA equal to 5 over 2 force of friction because I know that MA term is going to be down there. Okay? Dramatic pause. Okie dokie. Moving on to the next part. They want us to figure out what is the linear velocity as this object comes off of the roof. So I figured out the acceleration now because I have the force of friction. So I went back to the acceleration term. MA is equal to mg sine theta minus the force of friction. I can replace all those numbers, and I get an acceleration of 3.5 meters per second squared. I then use a basic kinematics equation. V squared equals V naught squared plus 2a delta x. V squared is equal to 0 initial velocity plus 2 times that linear acceleration times the distance. That should be an x there. That should be an x there. Make that a little bit more clear. And the length of the roof is 4 meters, so I get the velocity is 5.29. Okay, last part. This part sounds way worse than it actually is. That's usually what you should be noticing right now for all of the last parts on these problems. They're usually way easier than you think they are. The object's going to come off the roof, it's going to land onto a cart, and the cart has a mass of 12 kilograms, and they want us to calculate the horizontal speed of the wagon with that cart immediately after the ball lands in it. Right away, this is an inelastic collision, which means momentum is going to be conserved. That means the momentum in the x direction initial has to be equal to the momentum in the x direction final. The object coming off the roof has all of the momentum in the x direction. So what I did here was I used the inclined plane 30 degrees, the fact that this is 90. That must mean that this angle with the vertical is 60 degrees. I used that to figure out the Vx component, so that's going to be 5.29 times the sine of 60, and I get Vx is equal to 4.58 meters per second. 4.58 meters per second. Now I'm going to use the conservation of momentum in the x direction. All the momentum is in the bowling ball at the start, so 6 times the 4.58 that I found before. It's an inelastic collision, so both of these objects are going to have the same velocity, so I add their masses. 6 for the bowling ball, 12 for the wagon, and I get that the final velocity of the wagon is 1.53 meters per second. So this part right here is maybe the part you got to be a little careful on. The angle of the inclined plane was 30. That means that this side is going to be 90. The whole line has an angle of 180 degrees, so 30, 90, that means that this angle has to be 60. So I use that 60 degrees, and I'm using the sine of 60 to figure out that x component, and then I'm using the conservation of momentum to find the velocity of the wagon after the collision. So a lot going on in this problem. Please be very careful when you're labeling your forces. Figure out what they are asking for.